So a graph I think is easier in polar is the Rose curve. The Rose curve had an equation of r is equal to a um, a cosine or sine of n, not pi, but n of theta, and the rectangular is going to be the same thing, y, cosine of n x or bx. And then to graph these, right? So when we're graphing these, we know that if this value is 3, there are going to be 3 petals. So we can easily figure out the n value, right? So if we can figure out the n value, we can just go like, there's going to be 3 petals. We know there are 3 petals. And then to figure out the a value is just going to be this value right here. And if we graph this on a rectangular plane, the values are going to change because of all of these transformations. So they're going to go up, down. It's going to be hard to see that. It's going to be hard to see what the period is just by looking at it. So, but here, you can easily see what the pi is and what a is just by looking at it. And if it was 2, it would not cross. It will have. So we know that in a rose curve, if there are 2 petals, we know that there are going to be 4. So something like that. 4 loop-de-loops or 4 petals. So if there are not 2 petals. So if there are 2, this value right here is 2, there are going to be 4 petals. But then again, our period on the rectangular changes. So if our period changes, our whole graph again changes. But here we can easily figure out how many petals there are and how many. So our graph on the rectangular is gonna go straight up, straight down, and keep going. So my explanation for this is that it is way easier to just see and figure out all of the values like a and n, a comma a and n, by just looking at a rose curve. Instead, if we did it on a rectangular, it'll just be a squiggly line and it'll just keep going and going. Whereas if we did it here, it's just gonna be 4 petals, so we know that n is 2, and then we can figure out a. And we can just figure out a by looking at this distance right here. So that's why that's easy. So the rose curve is easier, but I'll say that a curve that is easier in rectangular form will be the limacon with an inner loop, because the equation in polar form is r is equal to a plus or minus b cosine or sine of theta. And in rectangular, it's the same thing. A plus and minus b cosine of x or sine of x, right? But here, when we graph this, it looks something like this. Then we have a loop here. We have something not exactly like that. Like so, like we draw a line of mod, and then we have a loop de loop like that. So now we have to remember that in this case, A over B, if it's a limacon with the inner loop, A over B has to be less than 1. And then there are other kinds of limacons, so we can get it confused with that. So if we graph, and then this value is A plus B, just not A. But if we graph it on the rectangular, it's just a plain and simple graph. Well, it's easier than the polar graph. So we just go up. We have a vertical shift, and then we just have a vertical shift, and then our period is a little different, but that period is just a little different, so it's just a little wider, so it's going to be something like that. So now we can see each and every point and where they are, so that's why that's easier. So limacons are harder. Limacons are harder to graph on the polar what is it? On the polar graph. Because there are multiple rules to remember, and all the values in the equation aren't visible to the naked eye. So that's my reason, and that's it.